Yeah, succession visualization. It's a topic on which you can spend hours and hours on, because obviously there are super many facets and details and interesting things you can visualize. You can probably also spend only 5 minutes on and say, well, use Excel and have fun. And well, I try to make something in between, where I will give you first, on the first couple of minutes, a rough introduction to why we do visualization, what is the main point, and then switching over to also for the last hands-on sessions to some real examples using this Colab service or Notebook Python service, and show you some code on how you can actually achieve visualizations that might or might not make your life easier in the future if you have some data that you want to visualize but didn't know yet how, or Excel and other tools just to give you the options that you need. The good news is that with these visualization tools that you can use programmatically, you have a lot of more options than standard tools give you, and you can also do much more of the processing and heavy lifting in the background. Think of bringing the data down to some level that you can manage, or if you have really large data sets, to first sort out what you need and what you don't need, and if all of this in one pipeline. Okay. Speaking of pipelines, I showed you this picture also some webinars ago. This is what people usually consider the kind of data science pipeline, or at least it has the main steps in the pipelines. I will not go through all these steps today. However, I just want to make sure that you still understand where we are in this model kind of pipeline idea. So there are questions and data, and then there's some wrangling, which typically means to convert the data that you have in some raw format into a format that is more appropriate for your tools, maybe. Not yet too much about cleaning and filtering and so forth. This comes later. Then there comes the exploration stage. This is what we will look at today. Modeling, validating is then more towards this analysis and machine learning things. And then at the end, usually, of at least most data science pipelines, is this tell the story. Tell the story then means, okay, I had this raw data, I had a question, now what came out of it? And one big part of tell the story is to visualize things. So to show the people who are supposed to understand it or to use it or to work further with it, to understand on some kind of visual level what your data means or what the results mean. So these are the two main blocks for today. This is very first initial exploration of the data, and to create then some visual tools, let's put it that way, that would allow to tell the story. Okay. Main topics today is, well, I will give you some ideas about the basics of visualization. Again, why are we doing that? What are the main things, the main objects that we look at there? Then I give you a super brief introduction into information visualization, as I'm like, again, what does it mean? Why do we do this? What's also maybe the contrast to scientific visualization? And then the most part of the day I will spend then on the hands-on examples to show you some code on how you can achieve all this. As usual, I will give you the link to these notebooks so you can play around with it yourself, or have it for later reference, or do it along with me when I show the examples, whatever you wish. But it's also perfectly fine to just kick back, relax, and listen to what I have to say today. Good. When we talk about visualization, I guess we have something in mind when we think, oh, what did I see lately on some news or some reports or the internet about visualizations? One of the earlier ones is this cholera outbreak map, where the houses were marked, and then at the end it was concluded that from these marks it could be, at least on a lower scale or global scale, inferred what could have led to these outbreaks, and so the dynamics of these outbreaks. So one of the super early visualizations of actually scientific data that led to something. In the middle, you have some typical demographic graphics, in this case from Ireland, from almost 10 years ago, where you can also see something that you have in your mind already some concept about. So if you hear about this demographic development, you have some tree structure in mind. And then there's a visualization that confirms that, or the other way around. Maybe you have it only in mind because you've seen it so many times. So also a good example for people to understand these kind of visualization. The data might be actually quite complex, but then seeing it visualized in that way might make it a bit better understandable, and also seeing the direct implications of that data, at least if you're into the topic. And the last one on the right is, in this particular case, because it was most easy to find, a government budget breakdown, a so-called tree map, in this case of Benin, from Africa, where you can see how much money of the budget actually spent on something. And also there you get the overall visual impression of what are the categories in which the budget is divided onto. So you also get quite a clear idea of whether there's some hierarchical strategy or what are the big parts and so on and so forth. So 3 very, very different examples, but all of them give you some impression of the underlying data. You might not understand everything that is presented there, but at least you get some first idea of how one could go about the data and maybe dig into more details if one's interested. Visualization, if you look it up on the internet or in some dictionaries, maybe even, you will get something like that as a definition. The first one is from this Oxford English Dictionary, also quite since some time already there. And that says to form a mental image or vision of something. So again, there is some data, say, in the background, and then the visualization forms something that you then mentally can proceed or understand or grasp, maybe even better. I love the term or vision, but let's stick with some image for now. And the second one is from the American Heritage Dictionary, that I like even better, to imagine or remember as if actually seeing. So if you actually would see the data, then you can also imagine something, some sense in it, or something that it should be transported or conveyed to your mind. So as you can see, it's not super descriptive, but it gives you the idea of what is meant by visualization. There's something, let's call it raw data. It can be very large, can be very complex. And the visualization makes something such that you can imagine what is inside the data. Maybe you can even see some patterns or something that is interesting. And then, that gives you a rough or better understanding of the numbers maybe that are underlying this. And the main questions for today, or for what follows now today, is, well, if you have some data or you are working with some data, what is it actually that you would like to show? And the 4 maybe main categories that people are usually interested in when it's about what would I like to show about my data is relationships. Relationships could be between variables. So if one goes down, does the other go up? If I get higher and higher, like my body gets higher and higher, do I also gain more weight? Is it connected in some way maybe? Composition of the data over time. So how does it develop over time? Maybe I have a company and I'm tracking the number of sold items, hoping that goes up. Maybe there's some seasonal trend or something like that I would like to track. Distributions is also something that we will start with today, which is also quite big in this whole visualization and then simple data analysis tasks. So how is my data distributed? If I look at random sample of 100 people from a country, say, what's the distribution of the height? So maybe I'm interested in the mean height of a random person, and how much does it go to left and right on the scale? So how many is it? Is it more that I have many small people and some large people, or is it that I have a little bit of everything, or is it concentrated on a particular height in the country? So how does it really look like? And then the last one, at least on this list, is the comparison with relation to something. So maybe I have categories. So again, I'm selling stuff on a company, and I have umbrellas, say, and sunscreen, and I'm interested how these categories develop over time. Do I sell more sunscreen in summer? Well, probably, and more umbrellas maybe in winter. So how does it really? How can it be compared? How can it actually put into relation? So these are 4 large categories that usually people are interested in actually analyzing or visualizing also when it comes to data visualization tasks. And then I found this graph, which I like a lot because it totally reflects what I just said, or was the other round, who knows? And the point is, it's a kind of cheat sheet where you can say, okay, if you would like to show some relation in your data and you've only 2 variables, well, then use a scatter chart. You want to have 3 variables, well, you could use a bubble chart. If you would like to compare something and you would like to compare over time, and you have a few periods and you have just few categories, well, then you're probably taking a column chart, and so on and so forth. So this is definitely not covering every single chart type that's possible, but it might give you some rough idea about, okay, what is it actually that I can visualize when I have some data, and I would like to see or to show some aspects of the data, maybe in these 4 categories, or maybe even something else that is not shown here, which you then have to either build yourself or find yourself. But this gives you a rough impression about what is possible, what is done at least standardly in simple data visualization. Okay. Now, obviously, we first have to start with data. So it comes with data, and that's what you want to visualize at the end. And one super simple example is, as I just briefly mentioned, distributions. Distributions in this case of heights. Here the data set was about students at a high school, and then they looked at these people and measured them, it's height in this case, and they were interested in finding out, okay, what is the distribution of people at our school? There are many example data sets that you could play with if you wanted to. There's one from a Lancet publication, and there's another one from statistics classes that you can just use or click on later when you have the slides. Now, the point is that if you have this data, it usually comes in a kind of tabular format like this, that has also usually some labels, what the columns actually mean. In this case, I omitted it because it's not too important. The point is you can see on the first column the gender of the people that were measured here, and then the rest of the columns you can see the height, and there's also more data than weight and so forth. Since it's US American data sets, it comes in inches and pounds, so don't worry about the original data. I converted it then later and then got centimeters out of it. And the point is that you can see here already quite clearly a signal in the data. You see that the female students seem to be smaller in height, and the male students seem to be larger in height or higher. And you can see some kind of distribution, as in, well, it seems to be kind of a normal distribution. It looks a little bit like there's a spike somewhere in the middle where the mean is supposed to be. And then on the left and the right, it seems to be somehow symmetric, which will then hints us towards a kind of normal distribution. So you can see that height is closely normal distributed in this data set, and that there's a more or less clear separation between a female and a male student when it just comes to height. There's not much more you can see here. It's just that is the main information that you would like to present, maybe if you look at this particular data. Now you could overlay this with weight and other things as well, and tons of other parameters if you had them. But this is really just a super simple example of I have tabular data, and I want to show in this case, histogram or distributions about the data, in this case with the attribute height. Another example is then maybe a little bit more complex or more complicated. Here we see meshes that have been measured by some sensor data or have been generated by some simulation experiments. And what you see here on the left, especially the grid measure points in this 3D visualization that is obviously behind that. And you're interested in, if I measure this from experiment or from some sensors, how can I show this now such that it makes sense? So the example here is much more complex than the one before. It's a very different data set, but it's also going from some first glance super meaningless data to something that is behind that. And in this case, some kind of spaceship that has been maybe modeled in some software, or maybe measured from some 3D scanner, or just having in some wind channel also. The point is that you can, having with some raw data, you can visualize in some way such that, well, for now, some image in your mind is created on which you can understand what this seemingly meaningless data actually means. Last example, also a bit more from the abstract side. What you see here on the left is some kind of website structure. So you see the websites that are containing probably something with students' life, and then within students' life there's housing and whatever. And then students also have some academics, website information from admission, registration, and so forth, something connected to health. And you can take all this information and put it into a graph or a network that you see on the right-hand side. And what you see here is basically the structure of the website. Certainly data is not complete here, but what you can see is that there is a couple of sites that are connected because they all stem from the same link, which is live, and then there's live housing, live dining, and so forth. So you could imagine somewhere in this area here, there could be the live link, and then from here it goes to live housing and live dining and live phone and so forth. So you can visualize the structure as a network or as a graph, and also can understand much better, okay, I have larger, say, clusters here or groups that are covering probably more of a particular topic, and I have smaller ones, and I have some that are coming from a particular central site, maybe that then links to the other subsites and so forth. So given some list of links in a way that you can scrape, or someone gave you maybe, you can understand or visualize how the actual structure of the underlying website looks like. Okay. When we talk about information visualization, we also have to talk about scientific visualization. We will talk today only, more or less only, about information visualization, because that is what usually people do in most of their data analysis or real life, where it's about converting raw data to something that is viewable and therefore hopefully better or at all understandable to humans. And the point is that this data, and that's the difference into the next one, does not have obvious spatial mapping. So it's not that we look at a point cloud as in a second example here, and from this point cloud, or from the points we are given, we are having some spatial representation in 2 or 3D. So from here on the top example, we go from some more or less abstract data to something that we visualize, because then we can get a better idea of what the data actually means. And the second example, that is scientific visualization, that is specifically concerned with data where we do have a 2D or 3D space representation, as in, again, measurement data or scanning data or sensor data, could be anything also from satellite data and so on and so forth. Again, today we talk about information visualization. Scientific visual is a different discipline, but yeah, has something else that we are today at least not really concerned. Okay, and then the second thing one needs to talk about, also just to make clear where we are not at least today, is that there is structured and unstructured data that one can talk about. Structured data is what we just looked at. It's roughly speaking tables. So it can be displayed in rows and columns or even in databases. Usually what's in there is numbers, dates, strings, text entries, category names, and so on and so forth. And this makes usually up to 20% of enterprise data. If you go to the internet, similar numbers exist, although I don't think that has been really measured. But about a fifth or so of the data that you're usually having in these large databases and also the internet, about a fifth or 20% is structured data size-wise. That's the point. So maybe there are many more items that are actually structured, but from the size, it's about 20%. What we will not look at today is what's called unstructured data, which makes sense because it's the opposite of structured. And usually by this is meant images, audio, videos, and so forth, where there is really no structure that is at least easily recognizable. So large texts, spreadsheets that don't have a real database kind of structure in the background. This is usually considered all unstructured data. And if you imagine that a video is probably size-wise much larger than a table, you can also understand that why much of the data or most of the data we see either in enterprises or even the internet is actually also taking up most of the space, because just from the sheer size of the files. Yeah, that's, I think, the main things you need to understand. So we talk about information visualization for structured data. That's more or less what we are dealing with today. Good. What's also then last thing important to understand is that structured data has attributes, which makes sense. If you think of tables in which the data comes in, then we usually have columns. And these columns usually have column names. So it could be customer name, customer ID, a name, a height, we heard that, a number of pets a person owns, if we're interested in that. And this is what the attributes are of a particular data point. Sometimes it's called dimensions. You probably have heard the statement, oh, wow, this data is super high dimensional. Well, that means that there's a lot of attributes for every row, for every item. Sometimes also called features or variables, which all means the same thing. So you can basically choose which one you like best, whether you say it's attributes or dimensions. And there's also something connected to dimensional reduction. This all is more or less concerned with the point that my row or my item has a lot of these fields that I can relate to. And again, in different contexts, it means obviously very different stuff. You can think of genes, for example, of a person, and then you probably have whatever many genes you're interested in, 20, 30, 40,000 genes. And then you can maybe for a person just make out how many of the genes are currently being actively used in a cell or so. So then you also understand, okay, wow, it could be actually quite high dimensional in this case, what my items are about. The main types of these attributes, well, are the ones listed here. So it's usually there's some kind of nominal type, which means there's categories, but they don't really have an order, at least nothing really obvious. In many cases, you can put some kind of order to it, but well, red, blue, green, you can maybe sort it according to the rainbow, and then you get your order. But there's normally at least no real order that we would apply to it. There's something like the ordinal type that is usually categories with some kind of order. Again, you could say, well, education level is ordered in the usual number of semesters you need to get it. So maybe a bachelor's, a master's, and a PhD. So there's clear order in how much time is needed to get those. There's something called a binary variable, which is also like a self-explanatory. It's usually yes, no, on, off. So only two states that the variable can take. Then there's numeric, which is also quite clear what that is. So quantitative information could be discrete, which is basically there is a, not necessarily limited number, but at least countable many. So we can say, well, number of pets owned, for example. Well, you don't have half a pet, right? You have only 0 or 1 or 2 and more, but it's clear it's only, in this case, natural numbers. There's continuous numbers, which is also clear, so can technically can take any value, height in centimeters, for example, or distances or so. This is then continuous numbers. And then lastly, well, there's also some kind of date-time main type, which you will always also often consider birthday, say, or date of last purchase or so, where one of the big problems I had, I can guarantee you, because there's many formats in which dates and times can be stored, and it's always a format you didn't think it will be, and then you have to convert things forth and back and so forth, time zones, which is usually not needed if you talk about binary or numeric data, for example. Okay, so important. You have, say, a table of people, for example. Every person then has attributes. This is why we have structured data, because it has attributes. And then each of these attributes has either one of these types or maybe something else, maybe just a limited list of things or so. But at the end of the day, this is the data we are often dealing with. All right, let's have a look at the first super simple visualization that we can do with a given data set. And this is connected to what we call exploratory data analysis. Exploratory data analysis, or EDA in short, means or usually is used to have a first idea of a data set that you might be given or that you're looking at anyways for some project reason or so. And that's usually used to summarize the main characteristics. And the point what we're looking at first is because we're looking for visual methods that give us some idea about these characteristics. And well, spoiler, it will be mainly about distributions of a variable. So say you have, again, this person database, and you're interested in the height or the weight or whatnot. And then you often look first at this kind of idea, how are my variables actually distributed? Is there missing data? So do we, on some of the rows and columns, miss entries? How much is that? How big is my data in general? So super coarse ideas about the data sets itself, but then that you can briefly grasp and quickly grasp it to get a very first idea about how data set looks like. And it builds then obviously on the understanding of relationships. And that's also what we will look at in a very small example. And we will mainly using summary statistics, something like mean, for example, about a particular variable. And again, very, very simple types of visualization to get a rough idea of what's happening. Okay, we will look and use two libraries that you might have heard before. I think I mentioned them also some time ago. There's tons of different libraries in Python or packages, whatever you want to call it. We will use Matplotlib and Seaborn. Matplotlib is still, I think this is still true here, the most famous library because it's very easy and quite powerful to use in Python. You can make it more or less the way you want it to look. It has tons of customization things. Think of colors, think of titles, think of styles. It has a lot of different chart types. Some of them you see on the right-hand side. And Matplotlib was, and you will see that also in the examples, invented a long time ago. Since it is very complex, it also takes oftentimes a lot of lines, code lines that is, to actually get the result you want. And then people thought, yeah, that might be a little bit too difficult, in particular for beginners. And then they created Seaborn. Seaborn is sitting on top of Matplotlib, so it's using Matplotlib under the hood, but it hides a lot of complexity from you. So you will see that also in the code we will be looking at that sometimes creating a simple bar chart or a line chart using Matplotlib can easily take 15, 20, 25 lines of code, but you didn't really do anything. And in Seaborn, it's then 3 or 4 lines because it just puts standard values basically to all these options and makes it look nice for you. And then if you want to customize it, you can do it again. But still, in the first glance, it hides a lot of stuff. Again, on the right-hand side, you see some examples. We'll look at some of them in the next couple of slides. But yeah, once again, go to the websites, check out the galleries there. There is much more that is possible and that is also being examples for than what I can cover today in this webinar. Good. So first steps, or first thing we will do now is that we will look at the very, very basic data set information. So again, this is usually what you do or what you at least should do if you get a new data set and you're not 100% familiar with it because you might not have created it. So you just want to get a very, very first feeling about it. So how big is the data set? Not only is it 10,000 observations or 50, but also how much memory does it actually require? So maybe it requires 17 gigabytes, and then you anyway have a problem because, well, you need to maybe get more powerful machines to actually use all this data. But you wouldn't know if you wouldn't have looked for it, right? If you just have a data set and load it, and yeah, it takes an entire hour to load it, but you don't really know why, then, well, yeah, maybe you want to just check the sheer size. And sure, if you've got the file on some email or some disk, you usually know how big it is, but oftentimes you also just download it from the internet. And then, well, at least you might want to have a look at it, how large it is in your memory. Second thing, you obviously want to know very early in the beginning what features are in the data set. Is it the ones I need? As the different ones? What types are those features? We will see in a second that sometimes it's not the type you need. For example, you need some kind of number, but the data brings you a text. In this case, it will be gender, where it will be female and male. But, well, we actually need numbers like 0 and 1 or whatever not. But we have to convert it first. So we would like to know this first, whether or not the format is right. And one last thing that is usually quite interesting to know, at least before you start working with the data, is, well, does the data have missing values? So can I actually work with the data, or is 95% of the data missing? Well, because people just didn't bother to put it in, or the data has been corrupted or whatnot. So just this super basic information, you didn't win too much with that. But if any of this fails or doesn't meet your expectation, you know already, well, it doesn't make any sense to proceed with this data set and I should do something else. Good. We will look at this notebook where I will send around the link in the chat now in case you want to work with me while we are doing this. Should lead you to the Collab page. Let me go back to full screen for a minute. Okay. The rest of the slide deck is now not too important for going on, but you might be interested to look it up later, which is just, well, there's a link to a book, actually quite old one, by Ben Fry, but it's still one of the books that take you by the hand and tell you, okay, good, you want to do this, here are the main steps and the basic steps, and he describes a lot of what you can do there. It's not overwhelming with, wow, there are 17 libraries and 500 techniques and so on and so forth. I think this book is, because maybe it's also that old, just gives you the main things and steps that you need. He identified these steps here. We'll just quickly step through them so that we know also later on in which of the process steps we are. So obviously, first is always to acquire some data, to download and create yourself, whatever you're interested in. In this case, it's a data set about regions in the US and their coordinates, and then their zip code at the end, so zip code coordinates and the region. And the idea of this data set is to visualize somehow where all the zip codes are in the US. So you acquire it first, then you can parse it. There will be then some indexing to understand because it's directly connected to the states, but you need to understand that this column here in my data actually is connected to some other index, some other table that gives me the state of this particular row here. So that's the understanding of the data and parsing of the data. Then you want to maybe filter or mine the data. That's what we will do next to just get a rough idea of where we are. Is it actually the right range here when we talk about coordinates, or is there something weird in the data? Maybe you want to see distribution, or for coordinates doesn't make too much sense, but could be also something else. Then you want to represent the data. That's now the actual visualization step. That might look like that you have all the coordinates that you get from your zip code data, and just put it into a map and see, oh, that actually does look like the US, and therefore seems to be done right. And then the last step, which we'll not do today, but also just for knowing how it works, is then you might want to refine the data and make it look pretty, and be able to zip and click into it and so on and so forth, make it maybe attractive. But that's then the last step of visualization. That is more needed for telling a cool story at the end, but not necessarily needed to really understand the data through visualization. It just makes it more pretty in many cases. Good. So that's basically the steps that we will also briefly go through in the hands-on example now. Again, I can recommend this book. I think you can actually get it today for like 10 euros or so, because there are many old copies flying around. So if you're interested in this topic and just want to have the basics, I really recommend this one. Okay. Now I will change my screen setup. That should be this one now. Okay. So you should be now able to see, let me remove this here, to see on the left-hand side, which we actually don't really need anymore, but I'll leave it open just as a reference where we are also in the pipeline. And anyway, on the right-hand side, you see my notebook, and that's the one I sent you in the chat. The notebook is more or less self-explaining. I put it some text here. You can see in between, where you can also, if it was too fast now, read a bit more on. I put you in the top 3 links, which might be interesting because partly I took the code from there, partly they have even more examples than what I showed here. So anyway, you can also click through those if you're interested. All right, let's get going. First step that we can also see on the left is acquire data. To make it more easy for us, I acquired now or loaded data from the internet. So we have an URL here. If you put this URL to a browser, then this happens. It gives you a table with, I think, 10,000 rows. You'll see in a minute. that has 3 columns, in this case, gender, height, and weight. Of course, you can just load your data from data set that you have. Then you wouldn't use a URL here, but some file that you tell it to Python. And what we do, and that is probably the only step that is noticeable, is that we load it into something called a pandas data frame. Pandas is a framework in Python, roughly speaking, a framework for using tables, or here it's called data frame. Not too important for the rest of today's hands-on. The idea is just that once we execute this, as I do now, what it does, it reads a URL, takes a CSV file I just showed you, and stores it in a table format it can use in the background. So it's now in this what is called data frame. Think of it as a table with some extra functionality. Next, I want to print some example rows from that data set. So I just say print my table that is called data null, and it prints me the first 5 and the last 5, including the header information. So we see, well, as we also saw the CSV file before, this more or less what it looks like, but now it has it already in a table form. So before it was in the CSV form, so it was separated by a semicolon, I believe. And now we have it in this already separated form where we have now a column for the gender, for the height, and for the weight, already in the correct data format. And then what we see is that the data is in US American units, so that's inches and pounds. And obviously, we would like to have it in centimeters and kilograms. So we are here now in the pass, or also understanding the data and maybe even converted phase, where we will now, not too important how this really works out, but we say it, okay, for every item in my data in the column height, please replace it by a value that is the old value times 2.54. That's how you go from inches to centimeters. And the same for the column weight, multiplied with 0.45 and so forth, because that's how you go from pounds to kilograms. And while we edit, we also need to change the column gender, because later on we will not be able to work with text, but we need it to be some number. In this case, we will use a binary value, 0 and 1. Sure I got this right here. Well, we'll see. Okay. Good. So we do this. We execute it. Now in the background has been changed. We again print our data, and we see now the values seem to make more sense, as a European at least. We have now gender 0, 1, and the height is, well, 187, 109 kilos. Well, still American data. Yeah, at least the values are now closer to what we expect from the metric system that we're using. Okay. Once we did that, we can now use the method info that our pandas data frame has, or our table has a method that is called info. And what we get here is then that we see, okay, it has 10,000 entries. It has 3 columns. First column is called gender. It is at the moment an int64 type. That means an integer value. So only full numbers, so 0, 1, 2, 3, and so forth. No comma numbers. But the next 2 columns are height and weight. These are the floats. That means they are continuous numbers, so can be 3.5 or whatnot. We have then a summary here from the data types that we have. We have 2 times a float and 1 times integer. And the memory that our data is using internally is 234.5 kilobytes, which is not too much. But sometimes if you get a larger data set, then there's easily some mega or even gigabytes here. And then you might want to think whether you still are in the right framework to pass your data, but at least you get the information. Okay. Then we can use a function called describe that is also part of this data frame table. And describe just gives you rough and easy statistics, so summary statistics. It says, for example, okay, on the height, I have a mean of 168. I have a standard deviation of almost 10. I have a minimum 137, the quantiles, and so forth. It also gives it for the weight. And now we get the first time a kind of idea how that looks like. So we have, again, the height mean 160. So we know, okay, that seems to fit. 73 kilos. Yeah, okay. Standard deviation, we also get some idea about the spread of our data. We don't yet know about the categories, really. So is maybe the female or the male higher or have more weight or so, but we get a really first idea about how that looks like. Not really looks because we didn't visualize it yet, but we have some idea about the statistics. Okay. Then we will use another function that the table comes with, which is called hist for histogram. And this is also super useful because what it does now is for all of my variables, I get now the summary statistics, but shown as histogram. So it's the first time in a super simple visualization. And this is also super useful because it says, okay, we only have two values for gender, 0 and 1, or that's how we set them. And we also get some rough idea about the distribution of our height and weight value. If the data had more entries, it would show more. So for now, it's rather boring. But the point that you get this with a simple command is, well, in my opinion, quite cool already, because you can do this also for more complex data set, and you see already, all right, there seems to be some weird distributions, or there seems to be something odd going on if there's maybe two modes, as we call it, so two main parts of the height or so. So we can really get the idea at the very first glance of the main statistics that we could get for the data. Okay. However, it still doesn't tell us if we look at the classes in our data, so in this case, gender, male, female, how does that look like then? And also Python offers a quite simple way of getting this or doing this. Why is my mouse now stopped? Okay. Which is called data group by. So I can now use the group by, I tell it the field, and then I'll say again, I want to have history, a histogram history for these two categories. And now what it does, it will do the same thing as before, but for each of the two classes separately. So you see it still looks similar. However, it now has the range in the female part is from 140 to 180, and in the range for the male part is 160 to, well, almost 2 meters. Same goes for weight. So the range is different. The distributions look still similar, but you get now already the first time the feeling, okay, there is some difference in the data, at least if we look on the gender specifics like height and weights. You can also then do it a little nicer. Again, now the code for that, I will not go into much detail, but just showing you what you can do with it. And then later on, you can look at the code if you wish. So you can also do it in one plot, what we just saw in many. So now what we do, we still go for the group by. So we group by the gender. We have now look at only the height value. We again want to have a histogram with some alpha so that we can have some transparent overlap. And now we see the two distributions for the height value for both of the classes in the same plot. And you see already, aha, still distributions look more or less similar, but there is a clear distinction between these two classes in our data. Okay, that was the super simple first part where, okay, I have data given, I have a table, in this case it's called a data frame, and I want to just play around a little bit with it and have the super basic information. What type is my columns? Is it numbers? Is it text? Is it categories? How does the distributions of the variables look like? Is there missing data? Is everything okay with the data? So there's this very, very simple, but first information we have now seen. We saw how this can be done. And we already have our first coolish looking visualization and where we have the two distribution overlaid over each other. For now, I show a couple of more types of visualizations. If you haven't seen them yet in your life, might be worth checking them out. What I want to show from now on for the next couple of examples is just to give you an idea about how easy it is to have the same data set all the time. We will have some more advanced ones towards the end. But for now, it's the same data set and just use different visualization techniques to look at the data from different angles. But at the end of the day, we don't do much. We just take the same matplotlib and later Seaborn and just tell it, okay, now show me a box plot. Now show me a line plot. Now show me this and this and this. But the actual code is largely the same. It's just that we showed you want to have another type. And yes, I know you can do similar stuff in Excel or other softwares like Tableau and whatnot they're using. But here you have the programmatic control over everything. So you can first filter the stuff, then you can change it maybe. Then you can do the colors differently. You can change the sizes and whatnot. And this to do with Excel and others is possible, but it's in many cases actually quite complicated to get what you really want, and you have to click through menus and so forth. And here you have it just in Python code, so you just program what you want. Okay. So next one I want to show you is called a violin plot. A violin plot looks like the following. It shows you basically the range, the main range of, in this case, again, the height for these two classes. And it gives you also distribution about it. So if you think of the histogram, then you still have the same shape that you saw before. And you can now also not only look at the differences basically in the classes, but also you get the both distributions of it and can compare whether maybe the distribution look fine like now, where it's more or less normally distributed, or maybe it would have some weird shapes that you could see and look at. And then you could really also understand, okay, the data looks like that. It seems to be maybe the same mean, but the distribution, like compared next to each other, looks very different. You could get a similar impression if you, as before, overlay the distributions in histogram, but now you get a little bit more information. You could also look at the quantiles if you wanted to, and the means and the range of the data. So you just have a little different angle of visualizing it in this way. The code for it is, as you will see, will be very repetitive over time. So at the moment, we just say, okay, the matplotlib, that's the one we're importing here. Please give me a violin plot. Then I give it the parameters. I want to show the means. I will not show the means. I want to show the medians. It should be a particular size of the graphic I'm showing. Should show the extrema. So that's all basically customization now. But the actual code at the end is just a first part where it says, okay, that's my data. I have two classes. I want to look at the height. And that's more or less it. And then I can make the colors to what I want. I can put labels and text to what I want, customize the axis. So all this is just customization. And then at the end, I show the plot. But the actual part for the visualization is this one here. So dear matplotlib library, give me a violin plot. This is my data here. That's all. And then if I just would use this code, it wouldn't look as nice as it does now, but it would give you also the similar information. Good. However, as you saw, these are quite some lines here, just to make it more or less pretty. If you would now use Seaborn, you can see that it's just from the sheer amount of lines, it's already a bit better. So I do the same thing. I show again a violin plot, this time using the Seaborn library. Looks more or less the same, a little bit different layout, but at the end it shows the same information. But I use much less lines to actually show the data. What I have to say here is, again, dear Seaborn, again, show me a violin plot. My data is this. I want to have these labels here. The gender class is the one I want to separate it on. I don't want to see a legend. I want to see this parameters, line width and so forth. I want to show the quantiles. These are these ones here. And then, sure, I want to have some labels at the axis and so forth. But again, from just the number of lines that you need, Seaborn is much better for you because it hides some of the configuration, but at the end shows the same information. So if you're interested at some point to really use these visualization techniques, Seaborn is probably the nicer library because you don't have to code as much. Okay. Next thing you might be interested in is to show some kind of feature-feature relationship. So in our case, we might be interested, is height somehow related to weight? And there is then, if you look at our diagram from before, scatter plot, one of the visualizations you would use. So we show now a scatter plot, very simple. We show a scatter matrix, in this case from the pandas library. And what we see here is that if you show a height versus weight, so you have the one axis for weight and one for height, you can see that there's a more or less linear relationship between these two. And again, it's just visualization. We didn't do anything yet. We didn't use machine learning or statistical tests or anything. We just have a visual impression of how weight and height are somehow related. And we can do this with just one line of code here. In this particular case, we could now also change the alpha values and whatnot, heights and so forth. We can again use Seaborn to do this. Then it looks maybe a little nicer again in one plot. And again, look at the number of lines of codes. It's 6, 7 numbers of lines of codes, where again, the rest is here a legend and so forth. And these kind of plots now becomes towards the advanced plotting, as in like it has more pieces in this plot. And to do this in Excel or your other tools might actually become close to impossible. But what we can here do with 4 or 5 lines is already visually quite pleasing, and it gives you actually quite some information, and the figures start to look actually quite professional for a publication, for example. So you see here again the distributions, and you see the scatter plot, and then you can see, okay, what is there in this data that I might be interested in. Good. The rest of the examples I would just actually execute and then show you. Here we have a bar chart that again is just the only more or less important line here is plot and bar. And then you give it the data, in this case, again, coming from a data frame. We just have to tell it what of the data frame data we want to, so which of the attributes you want to plot. And then looks like that. We can use the same data and show a line plot. The only thing we have to do now is to tell it, okay, we want to use this plot here. And then we tell it it's a line plot, but the rest is always the same. So the titles, the labels, and so forth don't change. So with one line of code, you can go through all the different options of plots that you can actually make. You can make an area chart. Again, most of it is actually the same as before. You just need to tell it now which kind of chart you want, called fill between. The rest is the same as before. You can make a pie chart. And I guess you guess the idea. There is now tens or dozens of these chart types. And once your data is suited for these kind of charts, the only thing you need to change now is to actually which kind of plot you would like to have. So now we have a pie plot. Again, before it was a fill between, so an area plot. Before that was a line chart. So the data doesn't change. The actual library methods only change in terms of the type that you want to use for displaying it, but the rest stays the same. Good. And then 2 last examples to also finish with this. Also, this can do a bit more advanced stuff, which you would probably not be able to do with Excel. This is what's called a word cloud. If you dive in a little bit into the code later, you will see that it reads a website, in this case, our WiNoDa website, extracts all the words that are on the website and displays a word cloud with it. You can do it with a PDF, with the text that you have and whatnot. So just visualizing something, whether or not the word cloud is the best idea for many things, a different question. But if you want to use these kind of techniques, it's 3 or 4 lines that you actually only need to be able to plot these kind of things. And then the rest of the lines just to make it pretty. So what should be the width and the weight and background color and so forth. But the actual word cloud itself is just 1 line of code that you display. And then last example, because some were asking also about 3D visualization. In this case, we're using a slightly different library, but just also to give you the idea about visualization itself, in this case, 3D. We're loading now a 3D file. Some of you might use this file format in their daily work. So what? Noted. That's how it looks like. It's a 3D point cloud data. So for each point that you will see in a minute, it has a particular 3D coordinate. That's often what you get from scanners, for example, from the field somewhere, for example. And then what you can do is you take this input, use another library, in this case, again, matplotlib with a 3D extraction, and you show how this data would look like if you would plot it. So now we're in the scientific visualization kind of area. But again, you can see this with 2 or 3 lines. Again, the rest is more or less only for making it pretty. You can visualize 3D data in a Python script or using these simple visualizations. And then last example I have to also show you that it doesn't have to be always boring and 2D. You can also actually, within these notebooks, have 3D visualizations that you can interact with. So you can turn them and zoom in and zoom out and so forth. And now then again, depending on your laptop, this one that we're using now is a quite old one and not very strong. You can also visualize quite complex 3D clouds or whatever 3D data you would have, and zoom in and then look at different parts of the data that you have and whatnot. Can then make other visualization techniques that maybe are different renderings, or do machine learning now on it. Show me all the items that have a particular shape and then plot them, and I can look through them and so forth. And just again, with only a couple of lines that you need, because there are these powerful libraries in the background that support you. Good. And with this, I am at the end of today's lecture. I hope you got a rough idea about that Python and these libraries or frameworks can do for you when it comes to loading data and representing data in some kind of visual form. We went through some very simple ones that you're used from Excel and other softwares, and then to a bit more advanced ones that look actually quite pretty. But again, the advantage over Excel and other tools is that you can directly load your data into these frameworks and directly go through a couple of different techniques and change it and make it nicer and filter it and whatnot. This is also for machine learning, show the machine learning results on it. And at the end of the day, hopefully it makes your life easier in the future. Take care. And if there are questions, please ask them now. Then you need to change two lines, or one line actually only. So either you ask some AI to help you with that, or you write me a message and then I can change it for you. But exactly, if you want to use it from your local data storage, then there's one line in the very beginning where you don't load the URL, but you load the file path.